So let us apply ratio. Step number 1 for the ratio test will be, we have to take the summation value itself is a un value, that is equal to 2 power n factorial divided by n to the power of n. And immediately I can find out un plus 1 value from un only. Where is the change? 2 to the power of n plus 1. And here we are getting n plus 1 factorial divided by n power n can be written as n plus 1 to the power of, come on, tell me, n plus 1. Every n will be replaced with n plus 1. Now we are
Yes, sir.
moving to the second step, that is, we have to find out un by un plus 1 value, which is equal to 2 power n into
And
n factorial divided by n power n. The second fraction will become reverse. N plus 1 to the power of n plus 1 divided by 2 power n plus 1 into n plus 1 factorial. Here I want to use this formula, that is, n factorial can be written as n factorial can be written as n into n minus 1 factorial. N into n minus 1 factorial. I want to apply this n plus 1 factorial, not for this. Usually students are applying for this. No, I am not applying for this. I want to apply for the denominator. Look at what
okay, sir.
happened here is 2 to the power of n into n factorial divided by n to the power of n into this I can write like this now, n plus 1 to the power of n into n plus 1 to the power of 1. Bases are equal, power should be added. We can split it. Even though I want to split here also, 2 power n into 2 power 1 here. Now we need to apply this formula, that is n plus 1 into, it is now becomes n plus 1 minus 1. And their factorial will be as it is. Now if you notice, here so many terms are cancelled. What are those terms? N plus 1 to the power of 1, n plus 1 itself it is cancelled. Plus 1 minus 1 cancel. Left over is n factorial. That cancelling this n factorial. 2 power n cancelling with this 2 power n. Okay, maximum steps. Maximum terms are cancelled here. Now if you move on, un by un plus 1. I found this question. So I thought it is better to discuss. 1 by n power n into, from this leftover terms, I want to take n power n common once again. Actually, I am taking n common, but once if it is coming out of this bracket, it will be coming along with the power. So it will be like that. And there, anything left over in the denominator? Yes, 2 is left over here in the denominator. Yes or
Yes,
no?
sir.
Yes.
Yes, sir.
Again, these two are cancelled. Now, finally, I have to move on for taking their limit. Okay, taking their limit. Apply limit intending to infinity for this term un by un plus 1. And there you can notice 1 by 2 is a constant term, will come outside. Limit intending to infinity 1 plus 1 by n whole to the power of n. Are you familiar about this formula? Yesterday we have already done the Cauchy's Yentru test now.
Yes, sir. What?
So what is this? This value is E now.
Yes, sir.
E by 2.
1 by 3.
E by 2 is, do you have a calculator to find out? 1.3591 I am getting, which nothing but greater than 1 only. So we say by by root test. No, not ratio test actually. By ratio test, you may have a question that why we don't apply the ratio test, root test. Why? Because factorial terms के लिए root test काम नहीं करे. By ratio
Yes,
test,
sir.
summation un convergent. Summation un convergent. Which is the end of this problem. This is completed. अच्छा एक और चीज I think I don't know. Want to ask you. आपके मैडम un by un plus 1 कराए या उल्टा करे un plus 1 by un करे? Don't know. Don't know.
Um, याद नहीं है सर.
टेक्स्ट बुक में भी un plus 1 by un ही है. बट मैं थोड़ा सा
Okay,
डिफरेंट
sir.
वे में कराता हूँ मगर आंसर पे कोई इफेक्ट होने वाला नहीं. देयर
हाँ,
इज
एक्सटर्नल एग्जाम में मैं आपका ही मेथड यूज करती हूँ सर. बस इंटरनल्स में क्या बोलते सो मैम के मेथड से करती हूँ मैं. ऐसा है.
प्रॉब्लम. आप
और
मैडम
आई
को भी
थिंक मैम इससे कुछ ज्यादा डिफरेंट नहीं है, ऐसे कराया जैसा है.
इसमें कुछ ज्यादा डिफरेंट रहता भी नहीं. एक और आई फाउंड वन मोर क्वेश्चन हियर. 1/2 plus 2 factorial by 8 plus, and believe me the questions which we are discussing now, these questions I have not discussed even in college also, because just now I found these questions. This series I want to test whether it is convergent or divergent. So let us start our work. Solution part. I want the un value. So for that, I am elaborating this series 1/2 plus. Can I write 2 power 1?
Yes, sir.
8, can I write 2 power 3?
Yes, sir.
Plus
लिख
3
सकते हैं.
factorial. Even 1 can be written as 1 factorial also. 3 factorial by 32 can be written as 2 power 5. Plus and so on. Now see the pattern. Using the pattern, we can go for its nth term, that is un is equal to 1 factorial, 2 factorial, 3 factorial, next term maybe 4 factorial, means n factorial is the nth term. 1, 2, 3 का nth term n होता. Denominator is, for every term we have a base is 2. 1, 3, 5 are the odd numbers. The nth term of this odd number is 2n minus 1. That's it. Now look at that. After getting the nth term, you have to verify whether it is correct or not. Put n is equal to 1. Don't start your problem with n is equal to 0. Otherwise, it is wrong. N is equal to 1. So what we are getting? 1 factorial by 2 power 2 into 1 minus 1 means 2 power 1 only. It is correct. Let us check for one more term. If you put n is equal to 2, we get 2 power n factorial means 2 factorial by 2 power 2 2 is 4 minus 1 is 3. Yes, of course it is correct. Now we have to move on for un plus 1. How to get it that? Every n is replacing with n plus 1. That is n plus 1 factorial by 2 to the power of, if I am replacing n with n plus 1 and I am simplifying, I am getting the answer is 2n plus 1 here. Do you want me to simplify? Otherwise,
Yes, sir.
yes, nothing is there. Just in rough column, wherever n is there, put n plus 1. What happened here? You see, 2n plus 2 minus 1 is nothing but 2n plus 1 only. Na?
Yes, sir.
This work you have to do it in
Oh,
our
अच्छा.
work, rough column. Now, next step is I want to move on for un by un plus 1 value. That is,
UN
एक minute.
by UN plus 1.
Un by un plus 1 value. Now,
N
you know
factorial
that it
by
is
2
the term will be as it is.
over 2n minus 1
2 to the
into.
power of, let me simplify some steps here. 2 power 2n into 2 power minus 1. Can we write like this?
ऐसा क्यों सर?
Bases are equal, power should be added, no?
तो इसको भी तोड़ देना अपन. ओके.
Yes, here also I can write like this. Like this. Divided by n plus 1 factorial. Are you getting?
Yes, sir.
Why? What is the advantage? Again, you may ask the question. This is the advantage. I want to
कैंसिल
cancel
करने
these two
में
terms.
आसान होता.
Yes. Now this n plus 1 factorial, I can use the formula which I am using so many times, can be written as n into n minus 1 factorial. This is proceeding here. Un by un plus 1 value is equals to numerator n factorial is there. Denominator 2 power minus 1, we can also write it as 1 by 2 into 2 divided by n factorial formula I'm using. That is n into n minus 1 factorial. After this, once again, look at there, plus 1 cancelling with minus 1, n factorial cancelling with this n factorial. Do not hurry, worry, that 2 and 2 will not be cancelled, okay? This is equal to, this will go to the numerator, 2 multiply by 2 divided by n plus 1. N plus 1, I would like to take n common here. We are getting like this. Now taking the limit, we have not applied the limit, now we are applying un by un plus 1 value, which is equals to 4 is a constant, will come outside. Limit n tends to infinity. What is there? 1 by n is there into 1 plus 1 by n is there. Now we know that as n tends to infinity, this is a particular term which will become 0, this one. Okay? It means we are getting
Yes,
everything will be 0 only. And we know that 0 is less than 1. Yes or no?
yes, sir.
Since 1 by n is 0, every term will be 0 if you multiply. So I can say by ratio test, summation un is convergent. Summation un convergent, which will be the end of this problem. This two questions I found very, very important question. And these questions I found in my notebook when I was the student of degree. My faculty told this question is very, very important. So discussing. So one more thing is we have already completed Cauchy's N-through test. You have any doubt in this, you can ask me. Otherwise, I think it is the
No, sir.
correct time to
No
move
doubt.
on for integral test. I have to move on. Shall we?
Yes, sir.
Look at that. Next page.
सर रिजल्ट कब आने वाले हैं?
Kal.
कल पक्का सुबह में आने वाले हैं कल?
Maybe. Actually, they are waiting for hackathon. It is done now. Integral test.
सर हम लोग को रहमत सर बोल रहे थे बहुत सारे बच्चे फेल होंगे M1 में बोल रहे थे.
Rahmat sir. कौन रहमत sir? अच्छा रहमत अली.
सीपी पढ़ाते हैं हम लोगों को.
Right, right. Dang, नहीं मालूम मेरे को भी नहीं. Statement. Okay, let me write the statement. Suppose that sometimes in exam they may ask you only the statement. Suppose that f is the function f is non-negative, decreasing function. non-negative decreasing function on here the interval is very important. थोड़ा interval को लिखने का तरीका भी देखिए आप. Closed 1 comma infinity and the bracket will be open comma and improper integral integral 1 to infinity f of x dx and infinite series summation n is equals to 1 to infinity f of n converges and diverges together. Diverges together.
Diverges.
I will explain this one, no problem, don't worry. See what I want to tell you, only simple word में बता देंगे. The convergence actually we are going to test f of n लेके f of x nth term लेके अपन चेक करते हैं ना. अब यहाँ
Yes,
पर
sir.
इंटीग्रल टेस्ट में अपन क्या करेंगे, we don't take the nth term, we have to take this improper integral. If this improper integral is converges, means it is suppose it is approaching to some value, then if this integral value converges, then this series converges. If this integral value diverges, then this series diverges. Converges,
Okay.
diverges together. That's it. ये improper integral पे अपना जो क्वेश्चन है वो डिपेंड करता है. अपन अपने क्वेश्चन को कुछ नहीं करने वाले हैं, अपन सिर्फ improper integral को चेक करने वाले. So to understand this, let me do for one question we'll be doing here now. To understand this concept more clearly, I think we have some formulas. If you don't remember the integration formulas, if you want, I will write it on the screen here. Do you know this one? Integration 1 by x square plus a square formula. What is this one? You know, it is 1 by a tan inverse of x by a. This formula I'm using in this integral test most of the cases, and I think you have to memorize all the formulas. And here we have one more. Integration of 1 by x is log x. And integration of 1 by x root of x square minus 1 dx is equal to, it is secant inverse of x plus c. Okay, just for revision purpose I wrote. Okay, let us go for one question. How this
Yes.
statement will be satisfying our problem, we can see with the help of one question. Question will be common every time. Test the convergence of, we don't mention here in our exam paper that which test we have to apply. Summation n is equals to 1 to infinite 1 by n square plus 1. Using, अच्छा एडवांटेज है ये तो आपको एक लकीली चांस है. यूजिंग इंटीग्रल टेस्ट, ये तो आपको मेंशन करेगा जरूर. क्वेश्चन पेपर में आपको पर्टिकुलरली सिर्फ और सिर्फ इसके लिए मेंशन कर देगा इंटीग्रल टेस्ट से करना है बोल। अदरवाइज दिस सेम क्वेश्चन कैन बी सॉल्व बाय यूजिंग एनी वन ऑफ द टेस्ट, बट वी हैव टू मूव ऑन फॉर यूजिंग integral test only. Now look at that solution. Summation n is equals to 1 to infinity 1 by n square plus 1. I can compare with the standard form, that is summation n is equals to 1 to infinity. I would like to compare with f of n. So can you tell me what is our f of n now? Yes,
One
value
by
is f of n. Yes
one
or
by
no?
n square plus one.
Yes. F of n is equals to 1 by n square plus 1. Definitely, on the basis of this, I can say that our f of x is equal to 1 by, what do you say? Just n replace with x square plus 1, that's it. Now taking the limit 1 to infinity on both sides. Integral 1 to infinity f of x dx is equals to बोलिए
1 by x square plus
integral
integral
1
1
to
by
infinity 1 by
x square
x
plus
square
1.
plus 1 can be written as 1 square into dx. So it's continuing integral 1 to infinity f of x dx is equal to, now you can see the formula. It's a perfectly this formula format now. Our a value is 1. So 1 by 1 लिखने का क्या भी जरूरत नहीं है. There is no need of writing. Simply write down tan inverse of x by 1, also no need of writing. And their limits will vary from 1 to infinity, which is equal to the rule of integration is upper limit is tan inverse of infinity minus lower limit is tan inverse of 1. And we know that tan inverse of infinity, it is not using the calculator. Trigonometric table 10th class pi by 2 minus this is pi by 4. ये कैलकुलेटर में आ जाएगा आपको, बट ये नहीं आएगा. So pi by 2 minus pi by 4 is how much? Pi by 4 only. So this integral value is approaching to some answer now. Integral
Yes,
f
sir.
of x dx is approaching to some answer. अगर इसका आंसर सपोज इंफिनिटी आ जाएगा तो अपन बोलेंगे डाइवर्जेंट. सो कन्वर्जेस. सो बाय इंटीग्रल टेस्ट क्या बोलेंगे अपन? बाय integral test, by integral test, integral 1 to infinity f of x dx. f of x dx converges. बट आपने इसको तो कन्वर्जेंस दिखाना है ही नहीं है. आपको क्या दिखाना है? What we have to show
Converges
hence,
and diverges together.
yeah, hence by the given statement of integral test, summation n is equals to 1 to infinity 1 by n square plus 1 is converges. This result we have to prove. Is it easy this test? बट आपको इंटीग्रेशन
Yes,
के
sir.
पार्ट में आना पड़ता था.
Okay, sir. थोड़ा रिवाइज करना पड़ता है इंटीग्रेशन का
Have you
सॉल्व
done
करने
this one also in your class?
हाँ सर मैम मैसेज कराए थे हम लोगों को ये प्रॉब्लम भी कराए थे शायद.
Okay, I can move on for one more question and then this session will be stopped. Okay, next page. Bari, Abdul Bari, come here. बैग में से लैपटॉप का चार्जर निकाल के चार्जिंग पे लगाओ. Second question is, yeah, charging पे लगाओ. Using integral test. हवा लगाओ. के ऊपर रखो, किलो के ऊपर रखो. फाइंड नहीं, पहले स्विच यहाँ लगाओ, उसका प्लग यहाँ पे लगाओ. ड्यू पिलो पे रखो, वो साइड पिलो पे रखो, इधर साइड पिलो पे रखो उसको, इधर दो, प्लग दो मुझे. ऑन करो स्विच. फाइन भी रह सकता है या फिर मैं तो सीधा सीधा टेस्ट बोल के बोल दूंगा. इंटीग्रल टेस्ट, टेस्ट summation n is equals to 1 to infinity 1 by n into n plus 1. This question we are going to apply again the integral test and we are checking whether it is converges or diverges. But I told you before also, everything will be depend upon the improper integral. Let us start our solution. Solution is given summation n is equals to 1 to infinite 1 by n into n plus 1 to be comparing with summation n is equals to 1 to infinity. To whom we have to compare? We have to compare with f of n.
Perfect. F of n.
So I can, what do you conclude here?
F of n is equals to 1 by
F of n is
into n
equals to
plus 1.
1 by n into n plus 1. From this f of n, I can also find out f of x here. That f of x is nothing but 1 by x into x plus 1. Okay. And here only I want to simplify for this. So क्या करेंगे? Yes. Here only I want to simplify. Subtracting, adding x, subtracting it. So once if you add and subtract x here, and this one will be taken in one bracket. If you split this one, we'll get like this: x plus 1 by x into x plus 1. From this minus, I can break it again x by x into x plus 1. This concept you can use it, otherwise you can go for the partial fraction. This also will help here. This also will work here. These two are cancelled. X and x also cancel. So what finally our f of x will be? Someone tell me. 1 by x
1
minus 1
by
by
x plus 1
1.
by x plus 1.
Now it is correct time to integrate with respect to x only, and limits are from 1 to infinity. ये समेशन के ऊपर देख के डिसाइड करो. If suppose it will start from 2, then do take from 2 to infinity only. This is integral 2 to infinity.
Integral 1 to infinity.
Oh, sorry, it is 2
Sir,
to
2 by clear?
wrong, writing mistake. 1 to infinity.
1 by x minus
1 by x minus 1 by x plus 1
dx.
to dx, which is equal to 1 by x integration is log x. Even here 1 by x is log x, that is log of x plus 1. Limits are 1 to infinity. And again, some of the students are again hurry, they'll apply the infinity and say that the answer is infinity, not like that. Log a minus log b can be written as log a by b. Log a by b. Limits are from 1 to infinity. What we do it here is, there is a very important step now. The numerator x will be keeping as it is. Denominator में से x को common ले लेंगे. We left with 1 plus 1 by x. And limits will be same. 1 to infinity. And the advantage of this one is we have to cancel these two. Now upper limit minus lower limit. Okay, limit upper limit minus lower limit. तो यहाँ पर भी क्या करना, बहुत सारे स्टूडेंट और बहुत सारे मैं तो देखा कई फैकल्टीज भी मिस्टेक करते हैं. इसका जो नेक्स्ट स्टेप है, you have to write clearly how we are applying the limit. Integral 1 to infinity f of x dx is equals to, here we have to write like this, limit x tending to infinity. What value is left over here is log of x by, not x, we don't have x. Here we have 1
by
1 by 1 plus x.
yes.
It is about upper limit minus limit upper limit minus lower limit. अपर लिमिट तो ये हो गई, लोअर लिमिट में लिमिट, लोअर लिमिट में तो कुछ होता ही नहीं. 1 by 1 plus लिमिट माइनस लोअर लिमिट, ऐसा आता देखिए लोअर लिमिट है ना, एक्स की प्लेस पे 1 रखते ना लोअर लिमिट में.
सर अपन इन्फिनिटी नहीं ले रहे.
अपर लिमिट में इंफिनिटी आता, अपर लिमिट इंफिनिटी, लोअर लिमिट में एक्स की प्लेस पे 1 रखना है. सेम क्वेश्चन को समझे ना बात को. हाँ, बट व्हाट हैपेंड अगेन, दिस पार्ट विल बिकम 0. So if it is 0, 1 plus 0 is 1, 1 by 1 is 1, means log 1 की value, this is nothing but 0 minus log of, here what you will get, 1 by 2, which is equal to minus log of 1 by 2 can be written as 2 power minus 1. And n log x rule if you apply, minus will come here, minus सामने आ जाता, minus into minus plus, it is log 2. Which value is log 2? किसकी value log 2 है? 1 to infinity f of x dx is log 2. Log 2 means it is converges, approaching to some answer. नॉनसेंस आ गया, शुरू हो गया. By integral test, by integral test, integral 1 to infinity f of x dx, क्या लिखेंगे यहाँ पर?
Converges.
Yes. And final answer is hence summation n is equals to 1 to infinity 1 by
Just
n into n plus 1 also converges.
converges.
Why? Because their behaviors are same. अब यहाँ पर लिख के लिखना है तो लिख सकते हैं by integral test improper integral and the summation behavior is same बोल के लिख सकते हैं. No problem अगर आप नहीं भी लिखते तो. So I think it is you are well understand this topic today what we have discussed today जो भी आज अपन करें ठीक है.
Yes, sir.
तो इंटीग्रल टेस्ट और भी कुछ क्वेश्चन अगर आप करना है तो कर सकते हैं. स्टेटमेंट इज वेरी इंपॉर्टेंट. तो ज्यादा क्वेश्चन तो एग्जाम में कभी भी नहीं आए अभी तक. क्यों नहीं आया बोल तो रीजन क्या है बोल तो लास्ट ईयर से अपने पास ऑटोनॉमस हुआ. लास्ट ईयर के क्वेश्चन पेपर में इंटीग्रल टेस्ट भी नहीं आया. इस बार हो सकता है और मे नॉट भी. इसके बाद अभी दो टॉपिक नहीं बोल सकते. एक ही टॉपिक है that is Leibniz test and conditionally convergent and absolutely convergent. If that topic is completed, unit 3 is also completed. Okay?
Yes, sir.
ठीक है, we'll end up the class now.